Good evening and welcome to Blast Point News, the show where everyday science turns into unexpected excitement. I'm Amin and tonight we're covering a surprising chemical event known as the Great Fizzy Explosion. Earlier today, a simple bottle of Coke exploded upwards after mixing with baking soda. Shocking witnesses see leaving shocking witnesses and a drenched snow surface. To get the full story, we go live to our field reporter Jerry. What's the situation?
Hello, Amin. I'm right where this took place, and it's right outside. All the witnesses are saying that they saw a hooded guy who was looking for tomfoolery, and now he's done such a dangerous act. You can see for yourself.
Let's start with the basics. What exactly happens when Coke and baking soda come together?
Great question. Coke is a saturated solution. It's already filled with carbon dioxide to the max. And then Exactly. It becomes a supersaturated solution when the base, which is baking soda, adds onto the carbon dioxide. And the coke becomes unsaturated once it explodes because it can't hold any more carbon dioxide.
So it's basically filled to the brim with gas already? So if the liquid can't dissolve with the gas, then what happens?
See, that's exactly why the coke suddenly explodes because it can't handle any more of the carbon dioxide.
Which explains the giant fizzy blast. Alright, I think the viewers are ready. Can you show us exactly how this happened?
Sure. Here's a video one of the bystanders recorded. They have requested that their identities remains closed.
Whoa, look at that instant pressure release.
Yes, and the temperature contributed a lot to this too. Right now, outside, it's negative 15 degrees. And on the solubility graph, which shows the solubility curve, we can see at negative 15 degrees, carbon dioxide is really soluble. And because of the temperature, it contributed a lot to the instant explosion. Sorry, I was cut off by the cops because of their investigation. What I had left to say was that the weather, the temperature, didn't directly affect the carbon dioxide. It cooled down the liquid, which increased the solubility of the carbon dioxide, which then increased the speed of the instant reaction. Here is a solubility curve graph. This graph shows the solubility of carbon dioxide in water while the temperature is whether 0 or 60 degrees Celsius. Now, the carbon dioxide wasn't in water, it was in Coke. But since they are similar and there is some extent of water in Coke, and there isn't any specific graph that was available for Coke, we'll be using this. Now, we can see that the lower the temperature is, the higher the solubility is, which helped the instant reaction. By the way, the solubility of a gas, in this case carbon dioxide, increases as the pressure increases. So we can conclude that the weather outside, which is negative 15 degrees Celsius, did contribute to this insane explosion. By the way, from the research I did externally, Coke is 90% water.
Some of my viewers over here are wondering, is Coke dangerous to have at home or it's safe?
Yes, it's completely safe to have at home, as long as the pressure in Pascal units isn't increased and the solution isn't made into a supersaturated solution. Other than that, the only time this is dangerous, Coke is dangerous for everyone, is when individuals, as seen in the video, get access to it and do such dangerous acts. And the officer has told everybody that the law enforcement won't tolerate any more of this type of behavior. So this clip shows more than the Coke just going kaboom, right? Exactly. It shows saturation, oversaturation, acid and base reactions. It shows solubility limits. It shows pressure buildup. A lot of things which we have learned today. You know what I mean? This reminds me of thermal pollution. That's when there's warm water added to the aquatic system, which increases the temperature of the water. Now, the reason that this reminded me of that is because over here with cold Coke and baking soda, we add it together, then it changes and it releases all the carbon dioxide. So all the carbon dioxide, not all the carbon dioxide, but a lot of it is gone. And that's what I find interesting and relatable here.
Okay, let's break it down one last time for our viewers. So Coke contains carbonic acid and dissolved CO2. So baking soda reacts to create more CO2, and then the Coke is already nearly saturated. So when the reaction occurs, it pushes it into oversaturation, and then the excess gas can't dissolve, which makes the pressure skyrocket. And then the pressure releases upwards, which causes an eruption or explosion.
Yes, I mean, you are right. Everything that you've stated is correct. And I've learned a lot from what happened today. And I also hope that all of our viewers also learned something new from this very bad and sad, tragic thing that happened today. We can, at the end of the day, take a good lesson out of it. And we can go home knowing that we've learned new stuff which will be useful in our daily lives. And again, if something like this happens, we'll have knowledge of why it happened and how to prevent any factors from contributing to it.
Thank you, Jerry, for your amazing details and explanation of this experiment. Thank you, Jerry, for joining us, and take care.
Thank you, Amin, again for having me here at Blast Point News today. It was a risky day reporting live at the scene where all this happened. And I've just been updated by the police that they have caught a suspect. Now, the investigations are still ongoing and they're still clueless as to why someone did this and how they were able to have access to this baking soda which caused such a deadly eruption. See you all later tomorrow, reporting live at Blast Point News.